So in the previous video, we have discussed about the execution of the fetch phase. Now the remaining part is about execution of the uh, remaining part of the instruction is about the execution phase, right? So what are the steps we have followed in fetch phase then? Those who have not watched the previous video, link is there in the description section. Please watch. So what are the steps we have followed? We have updated the PC and we have read the contents from MDR. That's it. How to update the PC? So here the step. Let us quickly revise it. Take the PC, that is PC out, right? Transfer it on to MAR. Now PC is updatable. Take it on to ZIN. Then select constant 4, read, go for addition, transfer it on to initially you have supposed to transfer it on to Y, then select 4. So Y and 4 both are given to the multiplexer. This multiplexer sends the data onto the ALU perform the addition, result is transferred to register Z. From Z, next step, Z out, take the content from Z, transfer it onto PC in, at the same time transfer it onto Y in as well. Okay, wait for the memory function to be completed. WMFC control signal it is. Then MDR and read the content from MDR. Okay, that is what read the what reading of what, that is the reading of uh, memory data register content, transfer it onto so instruction register. Okay, that is what about the fetch phase. So this is common for all the instruction follows straight line sequencing. Then here is the execution phase, R3 out, right? So execution phase, instruction comes into picture. So you are supposed to use the given instruction, right? Here in the question it is given R3, add the content from pointer register R3 to contents of R1, right? So R3 out, take the content from R3, right? Transfer it on to memory address register, go for, since R3 is of what type, R3 is of what type? Pointer type. R3 stores the pointer value, I mean address of the another register where exactly the data is stored. That's why whenever you are reading the address, MAR should come into picture. So content of R3 is accessed since it is a pointer, so transfer it on to MAR in. Okay, to transfer it on to MAR, you have to activate MAR in. That's it. Go for read the memory location, read the content in the location. Next step is what? You have to access the initial content of R1 also. If R1 is empty, there is no issue. Otherwise, see, there are probability R3 pointer which contains some value and R1 also already containing some value. Some value, let us say R1, let R1 contains some value, say 4. Okay, so it is to be accessed. How to access it? It is to be transferred onto the bus, right? So R1 should be transferred on, take R1, take the contents from R1. So R1 out, you can see here at step number 5. Hope it is clearly visible. R1 out, then transfer it on to Y by activating Y in, wait for the memory function to be completed. So two things are read now, R3 content and R1 content, right? So memory data register which stores the content of R3 now, take it out, select Y, this time Y contains what? R1. Okay, MDR out which is storing the content from R3, Y is storing, check step number 5, you will come to know, check step number 5 and step number 4. See, at step number 4, contents of R3 is referred to memory. So R3 address value is referred to memory address register, corresponding data should be referred out to memory data register MDR, right? At step number 5 you will come to know that Y is storing the content of R1, right? R1. Now this time both to be selected for to perform the addition. How to select? One is there at MDR, take it out, so MDR out. Second one is there at Y, use the signal select Y. Okay, earlier we have used select 4, that is different. Constant value. Now constant value you are not going to add because you are not in the fetch phase, you are in the execution phase. So Y has stored some value, Y has stored some content. Whatever the content may be, just select it. Select Y. Okay, this is something similar to Y out, that's it. Then perform the addition, right, as per the requirement, as per our requirement, perform the addition, transfer the result back onto Z. How? Activate Z in, that's it. Now it is to be stored permanently on R1. Z is a kind of temporary register, processor register. One more was processor register. As per the requirement, it is to be destination register should be R1. So take the content from Z. So activate Z out, right? Activate R1 in. That's it. Very simple thing. Here the diagram you can come to know. See the diagram, compare the diagram. Okay, write down the things, write the diagram one side, write the execution of the complete instruction. Both the concepts are very important. If you learn these concepts, no, 2-3 concepts, important concepts, surely you can score maximum marks from this module. See here what we did. So content of R3 we have transferred onto MAR. R3 where it is, right hand side, say R0 to Rn minus 1. Since R3 is a pointer register, we have transferred it onto MAR, right? Then what we did, MDR we have taken the content from, we have accessed at the same time we have also accessed the content from R1, right? R1 below R0 we have R1 bidirectional arrow you can find with the uh, centralized bus architecture. Okay, single bus organization. So contents of R1 is transferred to another register. Which register? Y. Another register Y. Okay. Then what we did? We have done the contents. Since MAR is storing the address of R3, its content are stored by MDR, right? So R3 content, actual content of R3, that is stored in MDR. Take it out. Since MDR has got a bidirectional arrow, so MDR out can be activated, right? On right hand side it will be transferred. Left hand side if you want to transfer towards memory, then MDR out E should be activated. Watch the previous videos, you will come to know, right? Then MDR out should be activated. Now MDR out content is placed onto the centralized bus, internal processor bus. Next we have what? So this MDR out is taken as input B for ALU, input A another input for ALU. You have to select the content from Y. Don't go for selecting 4. Okay, just ignore it. Left hand side of multiplexer you just ignore. Select the content from Y. What you will get? You will get the output of Y in place of A. So in place of A you will get output of Y. Then in place of B you will get output from MDR. That's it. Go for addition. Result will be, check the arrow mark, follow the arrow mark. Things are very simple. Result will be transferred onto Z. Then finally transfer it back onto, as per the requirement, transfer the content from Z to R1. Since R1 is the destination register, Z out, R1 need to be activated, right? Very simple thing. Please feel free to ask if you have any doubt. Okay, please write down this diagram followed by execution of a complete instruction. Okay, you will easily understand the steps. This is the sure question for exam, sure question. Okay, why I am telling this as sure? Because if you go through the previous year question papers, if you go through the previous year question paper, whatever the scheme may be, right from 2010 you can check. 2010 scheme is there, 15 scheme is there, 17 is there, right? And you are in 18 scheme now. You check the papers of previous schemes. Okay, things, these concepts were there earlier also. Even right for 2006 scheme also these concepts were there. You can find out, the question, and one question, as it is most of the cases the same example was asked. R3 is a pointer register, R1 is the destination register. What they may do is, so numbers, you should not mug up the things. So in place of R3 they may give different thing, like R2 also they may give R2 pointer register to R1. Okay, such probabilities are there. Please don't by heart, try to understand from where to where you are going to transfer the data, and whatever the question may be, first three steps will be common. First three steps are what? It is called as fetch phase. Later four steps, in case of if the instructions are different, then remaining four steps you should write carefully. Okay, let us continue our discussion in the next video. Okay.